Hello and welcome to the Car Care channel, and welcome to part 2 of the electrical series. Today we're going to be talking about diagrams, wiring diagrams for cars. How do you read wiring diagram for cars? I cannot tell you how many times I see technicians, they have an electrical problem and the first thing they do is start working on the car. That's actually a mistake. Wherever you're dealing with anything electrical, the first step is you need to pull the wiring diagram for the system that you're working on and understand how it works, because even if you are an experienced technician, you need to understand how this system is wired so you can actually effectively diagnose it and understand where everything is going and what's going on. And that starts with the wiring diagrams, and that's what we're going to focus on in this video. I'll show you an example and you can apply that basically to anything, and this is how your thought process should be. Having said that, let's get started. Let's take a look at this wiring diagram. We talked in part 1, if you haven't seen that, I'll leave it in the description. We talked about the horn circuit usually being the simplest diagram you will look at, and the simplest system you will look at. This is the horn circuit from a 2012 Toyota Camry. The wiring diagrams we are using are Toyota diagrams. This channel is focused on Toyota and Lexus. However, this information, you can use it on other manufacturers. They will have similar diagrams. Now, Toyota do have some of the better diagrams. They're color, they're really intuitive. In the past, they used to be more complicated, but now they've gotten really good, and they seem to be the better diagrams out there, in my opinion, complication-wise. So let's start by looking at this simple circuit. You notice at the top it says battery. That means this component is powered directly by the battery. Sometimes it'll say, if it says IGN, that means this component is only powered when the ignition is on. But in this case, it's constantly powered as long as there's battery power. From there, it goes to the fuse, 10 amp horn fuse, very simple. From there, we have a wire going out and splitting into two. That same wire splits into two and feeds the relay. In this video, we're also going to talk about relays and how they work, so we get how that works. From there, we have two branches. One of them goes to the horns themselves, and one of them goes to the switch. So here is something about electrical system in cars. You are always switching the ground on and off. But equally, if you can't do that, or you want to separate the circuits because you have a switch somewhere, I mean, when you look at it in the diagram, it's all on one page, but in reality, this is the steering wheel, this is the front of the car, this relay is in the fuse block under the hood, and this fuse is there also. So these components are not right next to each other. So how do you control a high current circuit? Remember we talked about amperage, a high amp circuit with a low amperage switch. Because if you amperage creates sparks, I told you amperage is what burns things, what fries things. If you put a very small switch, a delicate switch, to power a high amperage circuit, like in this case 10 amps, up to 10 amps, when you activate the switch, the tip of the switch will actually burn very quickly and very prematurely, and now we have problems. But how do you control a high amperage circuit with a very delicate small switch like the one that sits on the steering wheel when you press the horn pad? You do that with relays. Let's talk about relays for a little bit. We will depart from the wiring diagrams, so this will start to make sense. Relays. Let's draw a relay here and let's explain how this works. Now relays, there are many types. Let's focus on the most basic one. They usually have 4 prongs. Now the prongs are usually on the same side in the actual relay, but for demonstration purposes here, we're going to draw it like this. Let's say we have a component. This component is the high amp component that we want to turn on and off with a very small delicate switch. Now, this is grounded right here, so we need to supply power to this component. Well, the switch, the tiny little low amperage switch, is right here, and this connects to 12 volts. So we have power here, and then we want to power this guy. This switch, if you connect it directly to this guy, you'll activate it 2-3 times, the switch will burn because there's too much amperage passing through it. So here's how relays work. And I'm going to draw this upside down, so bear with me here. Now, to power this high amperage component, we need 12 volts because we already have ground to it. So let's say our 12 volt is right here. That's the source of 12 volts. We're going to connect it to one of the prongs of the relay. And then we're going to connect our high amperage load to the other prong of this relay, right here. How do we switch it on and off? Well, let's say we have a ground here. Relays will have an arm. Let's say this is the prong. They will have an arm right here. The arm is not touching that prong. And on the other side, they will have a coil. When you energize this coil, it creates a magnetic field. This magnetic field pulls this arm to close it and make contact. This is a very delicate coil that doesn't consume a lot of amperage. I mean, it barely uses anything. But this prong is a big, strong wire that is capable of carrying that high amperage. So when I flip my little tiny switch, all this switch is going to do is power this mini coil here. This coil, however, is going to generate a magnetic field strong enough to close my relay contact. And now this 12 volts and this wire that is capable of carrying high amperage will make its way here, and it's going to power my component. This is the most basic form of relay. There are a lot more different relays, and we're going to make a full dedicated video on relays. We talk about all the different kinds and how they work, but this is the most basic relay, which takes us back to our horn circuit. Now you notice here from the horn fuse, we have the wire coming down. This is a 12 volt, this is a battery, and it splits into two, and this is a normal thing to do because I can basically take this 12 source and connect it here. This is a low amperage setup. You can get power to this from anywhere. It's not a big deal. So what they do here is they split the same wire into two, and then the coil side, you see they even write it as a coil inside the relay. That's why I told you Toyota diagrams are good. They write the internal stuff most of the time. That wire goes down and splits into two areas. And this is where diagram confusions start. Wait, why do I have two switches? See, when they draw wiring diagrams, they put all possible configurations in the same page because they're not going to make, oh, there's a diagram for the LE, for the SE, for the XSE, for the one that has this steering wheel, and for the one that has cruise control, one that doesn't, one that goes to different markets in the world, and the one that goes to the US and Canada. They're not going to do that because sometimes there are differences. They're going to put everything in the same diagram, then they're going to give you the guide. In this case, there are two switches. One of them is, there's a star 1, and one of them is star 2. If we go to our guide here, star 1, it says with steering pad switch assembly. Star 2, without steering pad switch assembly. I don't remember the last 12 Camry that did not have without steering pad switch assembly. It will have to be an L model, which is below base level. So we're going to go with number 1. Number 1 goes right here, but then inside the switch, there are two more options. You could either have a blue wire or a very small non-colored wire. We have option 5 and 6. 5 and 6 are with paddle shifters or without. Paddle shifter models are the SE. Non-paddle shifter models are all of them. This is where product knowledge comes in hand. And then you have a switch. That switch is connected to ground. See how that works? So we are ground switching it. We're ground switching the relay. So when I connect this ground, it's actually going to send power to the relay, powering it, pulling the prong, and now we have power flowing to the horn. But the important details here are not really just how the circuit is flowing. We're using that for diagnosis. But I want you to understand beyond that. Every time you have a box, that's a component or some kind of sub-assembly. In this case, this box right here, it says right next to it, Spiral cable, that's Toyota language for clock spring. So this connection point happens inside of a component, which is a clock spring. And then this second component is the steering pad switch assembly, which is inside the steering wheel itself. Do you see how these are two components? And then when we look here, the relay, it also is a box with a color. That is a component. And then we go up top. The fuse is also in a box with color. That is a component. And we're going to look at a few other diagrams in this video, and you'll see where this gets a little bit more complicated. But then we go here. When you power this relay, this prong is going to come in. We're going to power our two horns. The horns, you notice that they are grounded to the body. We're going to send power to them. They're going to come on. There's the low and the high, usually horns, there's two. So this is, now we understand, wait, if my horns are not working, am I getting power to them when I hit the steering pad? If no, we're going to trace the power back. Do I have power going into the relay from the high amp side? Yes, that means this fuse is good and this wire is good. So now let's check. Do I have a ground here when I press the switch? If you don't, then perhaps we have a problem on this side of the circuit. There is no point at that point to go check the wires, ohm them, and flip the relay or swap the relay. There's no point. You have no signal to the relay. But if you have 12 volts at the top, if you put 12 volts here, the horns work. This switch is supplying ground when you press it. And I have 12 volts at the top. The only thing left in this case is the relay. The relay is not doing what it's supposed to. Simple diagnosis. If you have everything working but the horns are not working, you have 12 volts at the horns when you press the button, your ground is bad on the horn, or if the ground is good on the horns themselves are no good. You see how this, we couldn't have arrived at that conclusion without understanding how the system is laid out. That's very important. And something about diagrams, this is Toyota specific. Every component, except relays and fuses, will have some kind of a number or identification next to it. That identifies the connector for that component. And then on the second page, they'll actually show you the connector. But more importantly than that, right next to each component connection point, they'll show you a number. That is the pin number. So let's take an example here. The spiral cable. I want to find my wire. Let's say that wire is broken and I want to find it, pin it, and test it. It says connector B. We look at the diagram, the guide here next to it. Connector I-28 is connector B. Pin 9. So I'm going to move to the side. Where is I-28? I-28 is right here. They actually tell you this is a black colored connector. Pin 9 is right there. Now I know exactly which wire to check on the car. This is how you cross between these two. Otherwise, you're looking at a needle in a haystack. You have to know which pin exactly to look at. And this is what the diagram tells you. Now let's take a look at a different circuit. This is again from 2012 Toyota Camry with no smart key. The smart key, things get a lot more complicated and we haven't gotten there yet. So the starting circuit, the first component is going to be your ignition switch. This is what you turn and that's what starts the car. This is only the starting circuit, not the accessory or ignition on. You see, this switch has two prongs. One of them is AM1, one of them is AM2. These two switches are connected to two fuses. This fuse is AM1, it's a 7.5 amp fuse. You notice it's a lot smaller because this powers the control side. The other fuse is a much larger fuse. It's actually not a fuse. If you see this symbol, this is a fusible link, not a fuse. It's a 30 amp starter AM2. This is the big guy that actually turns the starter. So from these two wires, we go to the switch. The switch is a toggle. When you turn the key, these toggles connect and send power out. Now, from here, let's start chasing our high amperage wire first so we understand how this is wired. This high amperage wire goes down to the prong of the relay, the high amp prong side of the relay, which happens to be, just so I left this here so you can see it, which is this one. So now we have power here. From that, it goes out this side straight to the starter. And starters work in a very unique way, and we'll talk about that in a second. That's the high amp side. Let's talk about the low amp side, which is the other prong which has the 7.5 amp fuse. From here, it goes out and down and splits into two. And the reason for this two split, and this is where a slight complication comes. You have the neutral safety switch. This is very simple. Basically, if you're not in park or neutral, the car will not start. And the reason for that is you interrupted the signal to the control side of the relay, which is right here. The other one, though, is the ECM, which is engine control module. That can bypass the park neutral safety switch. It can actually connect the circuit and start the car, bypassing the neutral safety switch. That is why they wire the computer in it. But let's simplify, let's forget about the ECM for a second. Let's talk about park neutral safety switch. We need power to this little prong, which is this one. We need power here, so this would activate. The ground, you see it right here, goes straight to ground on the control side of the relay. So we're going to follow our wire. It's actually going to go through the neutral safety switch, up and back into the ignition switch where it gets its 7.5 amps. Pretty simple circuit. Let's talk about the starter briefly, and then we'll do a quick kind of diagnosis scenario using this diagram. Starters are probably the highest amperage component in the car. I mean, you will need a giant, very high amperage fuse to do that. So what car manufacturers did, instead of just having this giant fuse that will constantly be blowing, because when the car is cold, the starter will work a lot harder than when the car is hot, so they did a solenoid. So when you activate the side, this side of the starter, a little mechanical kind of relay will move, it will connect, and what it will connect is direct power from the battery, unfused. And this is why the power wire on the starter is possibly the most dangerous one, because it is unfused. It goes straight from the battery. You ground that wire, we're going to have fireworks. That's bottom line. There's no other way around it. But the high amperage side is that solenoid that moves and engages the mechanical connection to make that connection straight to the battery. And it also moves the starter forward to engage it into the flywheel or the flex disc. Having known that about the starter, let's talk about a diagnosis scenario using this diagram. Customer states, car does not crank. Okay. In any electrical diagnosis, the first thing you do is check your fuses. I see people jump into kind of very complicated components before they check their basics. Do you have power here and do you have power here? This is the first thing you check. If you have power here, is that power making its way to my first component? In this case, because this component is hard to access, you have to pull the covers, you have to do... So this is where you stop your approach and say, okay, I checked the very basics, which are fuses, the simplest thing to check. I'm going to go to the next accessible component to see where we're at. The starter is the next accessible component. It's a lot better accessible than your ignition switch or your neutral safety switch. You go to the starter. We have basically two wires. Modern starters will still have two wires. One of them is the big wire that comes straight from the starter. You check voltage there. Is that wire fried? Does it have bad contact? Is something going on? You have 12 volts there. Great. Then you pull the second wire, which is usually called the S wire or the control wire for the starter, usually a smaller wire than the big 12-volt wire. You check voltage there while you're cranking the car. If you have voltage there, all the components before it are good, because that means the control side of the relay, this side, is doing what it's supposed to do. It's pulling the prong, it is sending voltage, and it's making its way to the end of that wire. At that point, we're going to do a quick ground check on the starter, which is basically the body. If the ground is good, the starter is bad, the end. But now we have verified that 100%. But let's say this is too simple. You don't have 12 volts here. At this point, you need to stop. Don't go chasing random wires. Stop and return to your diagram so you can draw an action plan. You want to determine on your relay, we're going to split this relay in half. In our minds, this is the control side and this is the high amperage side. Where is my problem? Is it in the control side or is it in the high amperage side? That is very important that you distinguish where your problem is. So the next thing usually I tackle, and this is just a recommendation, it's up to you, is the relay. The relay is actually easy to pull out. You pull the relay and you start with the control side, because majority of the problems are control side, believe it or not, because there is not really a lot of real estate on the supply side. I mean, you got the switch, fuse, and this, but on the control side you have the switch, the fuse, the neutral safety switch, and this, and the ground. You just have more stuff. So you start with your control side. Am I getting 12 volts going into the relay control side? Like, let's say this one right here, or in this case, it would be this one right here. Am I getting 12 volts there when I try to crank the engine? If you don't, stop right there. Your problem is control side. There is no point for me at this point going to do anything with the high amperage side unless I figure out what's going on with my control side. So we move to the next step. We check the fuses. That was the first thing. Fuses are good, but is this power making it past components? That's the easiest way to check components, by the way. Power goes in, let's say a switch, power goes in, power goes out when you activate the switch. Is it that happening? You go check here. I have 12 volts going into the switch. I turn the switch to the start position. I have 12 volts coming out. This switch is good. It's doing what it's supposed to do. We're done. Next component, neutral safety switch. Neutral safety switch is super simple to diagnose because all it does is it's a switch that moves with the transmission. When you're in park, it makes contact. When you're in neutral, it makes contact. Any other transmission position, it's open circuit. That's all it is. Put it in park. Do I have continuity across it? Or better yet, easier, put it in park, check that you have power making its way to that component. You have 12 volts going in. Is there a 12 volt going out? No. Okay. Put it in neutral. Lo and behold, you have 12 volts going out. Now, at this point, you found your issue, but a quick verification, and it's really nice when you can verify this, you can actually put the car in neutral and try to start it. Voila, it starts. We have a bad park neutral safety switch. We're done, 100%. You're not going to be part cannoning this car. You know exactly what happened. But let's say you check the control side, and it's all good. I have power making it to the control side. The ground is good. I hear the relay clicking, but the car still doesn't start. This point, you're going to switch your diagnosis to the control side because we have a problem there. The first thing you want to do is check your relay. Is there power making it out of the relay? So if this energizes, it's pulling this prong, but is this prong actually making contact? Do we have power coming out of the relay? Let's say we do. You checked here at the relay, you have power coming through it. We're good, right? But then this is where diagrams get interesting. Because if we look right here, there is a junction connector. These junction connectors are used for assembly. You can't have one continuous wiring harness for the whole car. This will make the assembly impossible. So they section out wiring harnesses in the car so you can connect them together in pieces. And this is what this is. It says EA1. We look at our little handy chart here. EA1 is going to be this one right here, and it's a 2-pin junction connector. Basically two wiring harnesses joining together with that junction connector. We're going to go to it. Do I have power going into this junction connector? Because at this point, this wire going to the starter became 2 wires going to the starter, 2 sections. We know we're not getting voltage here, because otherwise the starter would work. And we of course checked that because we said this was the easiest thing to get to. I go to that junction connector. I have a red wire, you see it in the color print. By the way, wires are labeled by a letter next to them. That's what it means. When you have, like for example, in the ground, W-B, that means white wire with a black tracer. That's what that means. There's a little chart for colors. Every manufacturer will be different for the color. I go to this junction connector. On the red wire, I have 12 volts. On the black wire, I have 12 volts. That tells me that my junction connector is good. There's no corrosion, there's no issues, nothing is broken in that junction connector. At that point, here is the logic of diagnosis. I have power at this junction connector. I have no power at the end of this wire. This wire is broken. At this point, you're just going to chase it down the car, find where your broken piece is, or if you don't find it, it's internally broken, there's something wrong, run a new wire, quick jumper wire just to test that everything is good. Now you need to dig into the wire harness and find where it's broken. Very simple. If you have no power at the red wire, same thing. This red wire is the problem. But there's no point in testing the whole thing anymore. You have arrived at a point of the break. If you have 12 volts here, your problem is past the junction connector. If you don't have 12 volts here, your problem is between the relay and the junction connector. Case closed. We're not going to go start our diagnosis by replacing the starter. We're not going to start our diagnosis by replacing the park neutral safety switch or the ignition switch. That's a parts canon. You do your diagnosis. But how do you do that diagnosis and draw these conclusions if you cannot look at the wiring diagram and understand what it's doing? That is the number one thing you do when you do electrical diagnosis in cars. Look at the wiring diagram, get familiar with how this works, draw an action plan before you even go to the car, before you start ripping things and changing and checking. What are you checking? You have to know this. This is why wiring diagrams are super important, folks. And I hope this video now gives you a better idea of how to look at wiring diagrams. Look, we're not trying to re-engineer the car and understand how the space shuttle works. We just need to do our diagnosis effectively, and this is how you do it. Folks, I hope this video was helpful and informative. I hope you learned something new. If you like it, consider giving it a thumbs up. If you're not a subscriber, subscribe to the channel. Check out some other videos. And until the next video, folks, may the Lord bless you and keep you, and you have yourself a wonderful day.